Okay, first of all, I must know what is my population. The population is customers at a railway station ticket booths, correct? Customer that go there, okay? What is the variable that we are talking about? Time taken to serve a customer, correct? Okay. And the question said that for this variable time taken, they say it is normally distributed. So that is how I interpret. With the mean of the time taken to serve is equal to 45 seconds, and the standard deviation of time taken to serve a customer is equal to 20 seconds. That is what information I get from the first one. Okay, then after that, from the second sentence, you have only 10 minutes to buy your ticket or you will miss the train. Okay, so that means I will interpret, okay, before that, if there is a line of 11 people in front of you waiting to be served, so these are called, this group of people is considered as the sample. Samples of sample size. Can you tell me what is the sample size here? Are you sure? You don't have to buy it. 11 people in front of you plus you. So it's 12. So for these particular samples of 12 people, how much total time do you have? So 600 seconds. So when you talk about total time, in statistics here, how do we represent? Total means sum, am I right? Okay, so which means that my S12 is normally distributed or not? Is normally distributed with what mean? Huh? I 老人痴呆症 or you 老人痴呆症? How about S, standard deviation of the sum of the samples? No need to tell me the value. So since this is normally distributed, correct? And I want the probability that you will catch the train. Probability you can catch the train. Means probability the total time taken to serve all the 12 customers must be less than 10/600 seconds, correct? So can you find this probability now? What do you use? So to answer the blue part, you have to have the thought of the red, black part. So you have to be very careful. You are talking about total or you are talking about mean. You can just key into your calculator like that. So are you clear? That is how you do question 13. One. Okay, they say that the weight X of a particular brand of marshmallow has a mean of 6 grams. Okay, so what is our population? No, population, you don't say the weight. Weight is a variable. Is the marshmallow produced by this company? Well, I don't know which company is that, okay? Yep, right? So what is the variable? Yeah, weight of marshmallow produced by this company, okay? There is X. Did the question say X is normally distributed? No. So they just say that the mean of X is equal to 6. Okay, and the standard deviation of X is equal to 0.5. Okay, now they say marshmallows are sold in a bag with advertised weight of 280 grams, correct? So this is the total weight. Of how many marshmallow? 46. So we are interested in the total weight and the sample size is this one, all right? So that's why part A, they say, explain what the random variable S46 represent. Sum of the weight of 46 samples of 46 marshmallow, right? So I don't have to write that one down, huh? Sum of the weight of a sample of 46 marshmallows. Can or not? Okay, now B. Find the mean and the standard deviation. This one, no problem, am I right? Very straightforward. Mean of S46 is equal to 46 times 6. Standard deviation of S46 is square root of 46 times 0.5. Everything in gram. Okay? Now, C. Is S46 normally distributed? The answer is yes. According to CLT, central limit theorem, and the rules of thumb, n equal to 46 is greater than 30. Done. Right? So now part D. Okay, part D, they say that find the probability that a random selected bag contains 46 or fewer. Okay, look. Probability, a bag contains 46 or fewer marshmallow. Okay, let me explain to you. Because they said that the machine will stop if the total weight is 280, correct? So when the total weight is equal to 280, the machine will stop. That means it won't fill in anymore. So that means that bag will have 46 marshmallow, right? 280 divide, you got 46 marshmallow. But if the total weight of the marshmallow, 46 marshmallow, is beyond 280, so it will stop at 280. That means the number of marshmallow in the packet will only be maybe 45. I don't know. So that will be the fewer. So as long as the total weight of the 46 marshmallow is more than 280, the bag will have 46 or fewer. Agree with me? So that is how we come to a conclusion that this must be probability of S46 is greater than 280. Understand my explanation? Okay, so since our S46 is normally distributed, we know the mean, we know the standard deviation. Can we count the probability? Yes, you do normal CDF. No. No. 1 minus less than is the same thing. Well, why you want to trouble yourself? (46 times 6) and square root of 46 times 0.5. So what do you get? 0.119. Okay, listen here. If the label there lah, I say this bag contains at least 46 marshmallow. Do you think the claim is justified?
No.
Okay, why not?
The probability of there being 46 marshmallows and 280 that is too small.
It's too small, yes. Because if you talk about 11% of them is contained without 46, I think it's too high already. Am I right? Yeah. So that's why sometimes when they put all this, correct, they have to be very careful with their label. Hello, sleeping ah? Okay, another 10 minutes, I let you sleep. Okay, when we talk about question 16, what is the population? Adults, male. Right? Okay, what is the variable of the population that we are interested in? Yeah. W. Weight of adults. Adult male, adult males. Okay, now, is this normally distributed? Yes, it's normally distributed. So it's the mean of 73.5 kg and the standard deviation of 8.24 kg. Okay. Now, they say a leaf So I don't know how many people can go inside. So this is my samples of sample size N. I don't know. I don't know how, because I don't know what is the recommended number of people. Okay, but I know the total weight you can take. So 650 kg is the maximum total weight. Okay, so now I'm talking about SN distribution, correct? Am I right? Because total weight. So this SN distribution, is it normally distributed? Yes. This is normally distributed. Why? Because W is normally distributed according to central limit theorem. Am I right? So that is the reason. So what is the mean of Sn? Do you know what is n? Don't know. You just say n times of 73.5. What is the standard deviation of Sn? You don't know n, you just say square root of n times by 8.24. So what the question one is, they say that what is the maximum recommended number of adults male that should use the elevator at any time if you want to be at least 99.5% certain that the total weight doesn't exist. See, I want probability of total weight, that is Sn, doesn't exist. What is the probability? Minimum must be 99.5%. That is 0.995. And the question says hint, start with n equal to 9. So you have to do it by try and error. So you put n equal to 9. Then you do normal CDF. Negative 10 to the power 99 because there is no lower boundary. 650. Now the n is 9. Put it in and count the probability. What do you get?
Something like
0.321. So you see 9 people doesn't exist, is so low. Should I go for 10 or should I go for 8? Yes. So now I put n equal to 8. And I count. Same thing. Just here you put 8. What do you get? 0.996. Is it more than 0.995? Yes. So what is the maximum recommended number? 8. Okay, now, how the book give the hint of why it start with 9? If I didn't give you a number, how are you going to judge? Yes, they take 650 divided by 73.5. You got approximately 9. That is how they get the number.
I did probability of S9 more than 650. And then one very high number, so then I get S8 very low number.
Up to you. Okay, now Let me teach you. I can also do this by using solver,
Wow.
even without trying the number. Okay, everyone, go to your solver, key in your E1, normal, CDF, negative 10 to the power 99, 650, 73.5x, comma, 8.24 times by square root of x. Then E2, put 0.995. Then solve. You also can get the answer. Right? You got 8.0 something. So you always round down 8. So solver is very useful.
What function does normal CDF always say?
Normal CDF,
Yeah.
you find the proper integration.
Integration. Oh.
Then go home already.
Okay, done. You can go home already.